No, it's like, I think it's broken. Like literally it's not on. Could you hear the previous fans where you were sat? But these ones you can't, can you?
Is it on?
Yeah, it's on. Like literally, I'm this close. I can't hear it. Even now I can't hear it. Come closer, come closer.
Just about.
So this is NOCTUA's first liquid cooler, and apparently this is an insane one. So we're gonna check it out. We've got the 240mm one, 360mm one, and 420mm one. Now, there are lots of little things that NOCTUA has made changes of and improved because they have partnered up with, as you can see, ASETEK. But what exactly has NOCTUA done, apart from just slapping on some of their best fans and then calling it NOCTUA? There's lots of little things underneath that they have improved. So let's take a look what NOCTUA claims to be like game-changing performance, because we know they want to be silent, and then actually test it on this side to see if there is a difference.
It's so annoying. I don't want to pay hundreds of dollars to just change my Windows wallpaper just because my Windows isn't licensed.
Well, why don't you try Hookies? That's a ton cheaper, and if you use the code TN20, you get it even cheaper.
What do you mean? How do I get it and how is it possible?
Well, see this video here, or the one you're watching. Click in the link on the video description, add the Windows 11 CD product to the cart, proceed to checkout, add the code TN20 for the extra discount.
So what, the Windows 11 Pro OEM key is just $23.22?
Yeah. Choose the preferred payment option and complete the purchase. The key will be available on the purchased orders in a few moments. Copy the key and paste it into your Windows activation settings, and you're all done.
Oh, that was easy.
Is that Ryan Gosling?
No.
Anyway, by the way, the same discount code also works website-wide, so go check out other products, maybe like Microsoft Office. Firstly, what NOCTUA has done in here is this pump cover design on the top there. And they wanted to make sure that the pump that is underneath that housing, just above the cold plate in there, would be as silent as possible. So what they have done is a 4-layer absorbing underneath here. And you can see what's happening there is underneath there's going to be the pump. Then there's a bit of foam right on top of the pump. Then 2 is going to be dense sound barrier. Number 3, there's going to be some more acoustic foam, as you can see in there, the number 3. And then there's going to be a floating silicone mount for all of it. So if I'm just going to move this, you can see that the whole cover is actually slightly squishy on top of it. It moves to make sure that the pump noise in there would be as silent as possible. And they have claimed that there is 3.5 decibels noise reduction over ambient when this is installed there. Now, another thing that's improved with their cooler is the SecuFirm 2 Plus mounting system. And this is basically to ensure that there is the best contact with your CPU, because the most even contact and the most pressure that you can apply evenly will result in better cooling performance, because we're just able to release the heat from the CPU more efficiently, and we're going to see that in a minute once we install that. But you can see that with stock mounting or SecuFirm 2 Plus mounting, we can see quite a big of a difference in there between the blue and green graphs, as you can see. And on this graph, you can actually see how much better the SecuFirm 2 Plus is in terms of the pressure on either AMD or Intel. You can see that the pressure is so much more evenly spread. You can see the CPU IHS so much better in there, which means it's just much better at putting the pressure equally onto the CPU. But there's also offset mounting available because Intel and AMD have the hotspot on the CPU at different places. So you want the cooling center to be like as much above the actual CPU hotspot as possible. And they've got the offset here as well. Then, if you look very closely on this side there, you can see that the pump has a little switch in there. And there are 3 different options for the pump speed. On default, it's all the way to the right, if you're looking at it, and that is the quiet mode. Then in the middle, if we move it into the middle, Then it's going to be balance mode. And then on the very left is going to be manual mode, where the pump can go up to 3,400 RPM, as we can see in here. But there are different modes on the pump. And you might be saying, well, why don't you just give us the full speed and then let the motherboard actually optimize? Well, the thinking here is that why would you want a louder, faster pump speed if the CPU performance is not affected by it? Yes, maybe we have a little bit cooler CPU temperature, but if the performance is the same, wouldn't you rather have a quieter pump? And that's what NOCTUA is thinking in here. And even if you leave it at the quiet setting, if the liquid temperature inside there goes above 45 degrees, it still can push above the 2100 RPM mode that it's actually like the ceiling is on the quiet mode. If the liquid gets above 45, it's still gonna go higher than that. Quiet is the one where we can get just the most silent performance, but still insane performance. Balance is where it's maybe slightly louder and then you get more performance there. And then the manual is like if you want to adjust it on your motherboard and you have complete control to have it maximum or not, then that's the option for you. I think for most people, leaving it on quiet is the best option because we still get the best noise. But if you need to, you get better performance. So as you can see here, it's all explained a little bit better, which different modes, what RPMs you can do there. Here you can see that at 100% pump speed, there is quite a big difference, that the manual mode is almost double, even though this is not like linear graph here, the way the noise works, but it's quite a bit louder than just manual mode. Now, this is the bit where we actually see, is there a difference in cooling or not? If you look at 145 degrees load from a Ryzen 7 9850X3D, you can see that there's 2 degrees difference, which means that there's going to be no thermal throttling. It's completely fine, but it's just going to be a lot quieter by having it on quiet mode. No real performance difference versus manual mode having the pump full speed and being loud. At 200 watt load now, there's only 4 degrees difference. And at 350 watts, we have 6 degrees difference. Now at that point, at 350 watts, if we're not thermally throttling, does it really matter if your CPU temperature is 79 degrees or 73 degrees? At the higher temperature, you're gonna be so much quieter. I'd probably prefer the silence over the extra noise. Now, on top of this CPU pump in there, you can actually buy a fan separately. We've got this in here, auxiliary cooling fan, and that really is mounted magnetically on top of this. This just goes on with magnets, I believe, like that. There we go. And what that does is have extra VRM cooling for your power delivery, which can result huge differences in here. So what you can see, NOCTUA showing the difference in here is with the fan on, we're seeing the hotspot at 50.4 degrees. And then without the fan, it's 68.4 degrees. That's like 18 degrees difference, which is massive. We're gonna try that as well and how much actual noise this applies. But what NOCTUA is saying is that when you have this installed, the case fans usually make a lot more noise, especially running them at higher speed. You're not having to run the case fans as loud speed as having this fan on that CPU. So we'll try that as well. Obviously inside there is the ASETEK EMMA V2 pump, which is whatever generation. I think after 5th generation, they started to name the pumps at different names rather than numbers, which is confusing for us, but nice for them. But it's a lot more power efficient, pulling only 16% power compared to the version 1 of the pump. And there's a 3-phase pump, and there's improved cold plate and all sorts of things that ASETEK has done from their side to improve the cooling and liquid flow and just cooling of that plate there. Now, the other interesting thing that NOCTUA has released is whether you wondering if I should run the actual fans at push, which right now it's push, which means that it takes the air, pushes it through the radiator and out from the back, or if we should have them at pull, if you move the radiators on the other side, so it would pull the air from this side of the radiator through, or you should have them as push-pull configuration, which means you have fans on that side and this side. These fans push and the other fans pull the air through. Now, obviously, if you have fans on both sides, that results in a lot louder environment because you just got more moving parts, But what I found here interesting on NOCTUA's graph is that the push-pull configuration isn't actually better in performance. So if you look at the yellow graph in there, the yellow graph is higher than on the green graph. The green graph shows that if you've got them in push configuration, which is like that, it is actually better performance than having them push and pull, which I did not expect. Now, and finally, you might be thinking, should I go with the 240mm, 360mm, or 420mm radiator sizes? The thing is, actually, the 360mm radiator is probably the best sweet spot for most people. We would think that the bigger 420mm radiator with the bigger fans is better in terms of the cooling performance, and that's true because it's got more brutal force to just cool a bigger radiator. The liquid temperature is going to be cooler, but the blade versus fan area is not going to be as good of a relationship there because the 120mm fans have a better blade to fan ratio, meaning they're much more efficient in terms of power versus noise. So if you just want the best cooling capability, 420mm, because they just push more air through. The 140mm fans push more air through and they will be the best performance. 360mm one will be the performance for most people while maintaining the best sound to performance ratio. And the 240mm is just for people who don't require that big workloads, whereas this is completely fine. Maybe MATX cases, or even in some of the high-end ones. This is such a good cooler that even the highest end Intel and AMD chips should be cooled with that. Then the last question you might have is, should I actually run my pump speed as fixed, or should I have the pump speed as kind of linear graph? So as the temperature rises, the pump speed kind of flows with that as well. What they're saying is that if you have the pump speed at constant flow, exactly the same RPM, what that means is the liquid is just going to start to flow around at the same speed all the time. Because your PC doesn't move, there's going to be no movement in the rest of the things. The liquid just starts to move, which means that it may gather certain bubbles at certain areas of the radiator and pump. So when sometimes on the pump side of the things, or sometimes on the radiator side, which can result in higher noise. But if the pump ramps up and down, whereas the flow of the liquid is just changing slightly, that allows the bubbles to not get stuck in one place but kind of move around and result in overall lower noise performance. So then, let's try to mount this in here. So this test bench here has the 9950X. We've got ROG Rugin, something like that. So this is a few generations old ASETEK as well, obviously. But I've got the Fantix T30 fans on there. They are obviously a lot more performance fans, different kind of setup, but I want to see how this maybe a little bit of an overkill setup would work on there. And let's press go on the multi-core. I've got the noise in here and let's take a look what happens. So what just happened, we ran a consistent 200 watt load. We had about 47 to 49 dB ambient noise of the pump and everything. So if I'm going to be quiet for a second, you can see that at idle, we're around 42, 43, something like that. So I want to see if even the idle performance will be any different with NOCTUA. This was completely cold start for this as well. So we have in equal measurements. Let's turn it off, get NOCTUA installed, and then see if it's any better. So I'll also install the 360mm one. So inside the box we have thermal-based guard, which I should have used before as well. So we'll have that installed just over there like that. Then NOCTUA gives you a screwdriver. This is a little Torx screwdriver that NOCTUA gives you. Intel parts, AMD parts. So I assume it goes like this. We pop these in. And I'm probably going to install it south. So the AMD cooler should be installed like that so that the brackets are on the outside. But since we can try it, let's put the offset mounting as well. Standard mounting would be if I use these secondary, like lower screw holes. But if I move the upper one down by one, there we go. Now it should be the offset mount as well. Because AMD's chips are just on the lower part of the CPU, that your cooling center would be further on the low, because you don't need that much cooling on the top there rather than on the bottom. Now, we're gonna apply thermal pastes, but you might be thinking, why not use this? The carbon nanotube thermal pad that NOCTUA actually gave me when we were at Computex was like, hey, do you wanna try one of these? We're gonna do a separate one about this piece because that is very, very interesting. But for this particular instance, I would not recommend this one in here. If you're using AIOs, don't use this one. So thermal paste, we put a bigger blob in the middle and then little blobs around it. That should be the perfect application. Remember to remove this film underneath. Look at that, there's like an actual circle that's built into there as well. This goes onto there like that. Everything is metal in terms of the contact there, which I'm super happy about. Now, this we're gonna put exactly in the same place as before. Okay, NOCTUA gives you a Y splitter or double Y, if that makes sense. So you've got a three-way splitter, which means that we can put all of these fans together. And the cool thing is these fans are A and B fans, which means that they all run slightly different RPM, which means that you should put ABA or BAB in here, which means that the same RPM fans aren't next to each other, which means that we're not going to create resonance or harmonies there. So we're going to have to put this on top there, maybe like that. Okay, it's installed. I'm gonna put this roughly in the same place. As you can see, ambient is just 40 here. On idle, we're already a few decibels lower, around 41, 42. And I can like visibly or hearably tell you the difference because could you hear the previous fans where you were set?
What, the black ones?
Yeah.
Yeah.
But these ones you can't, can you?
Is it on?
Yeah, it's on. Like literally, I'm this close. I can't hear it. Even now, I can't hear it. Oh my word. Obviously, that's NOCTUA's like premium tech even on the fans because the fans are so fine-tuned with all the audio and everything. Okay, and start. I can't believe this. You know, it's doing the main, like same 200 watts right now. And it's as if it's not on. Like it's literally the same as if it's on idle, but it's pulling 200 watts. It's literally like the idle performance. Like right now, the CPU is at 69 degrees. Previously, we were allowed 75, so we're 5 degrees lower, while everything is at like minimum. This should not be possible, to be honest. I can't quite believe this. Look, we're like 41 decibels right now. Previously, we were 49 to 46 to 49, 47 to 49, it hardly makes any sound at all. So if this was inside the PC case, you would never hear it.
No.
I can't hear it from here. Like I can hear the cars
You're on the
outside.
side where the fans would actually go
Yeah.
as well.
No, it's like, I think it's broken. Like literally it's not on. Maximum temperature, 70.2 compared to 75.2, which was extra 5 degrees warmer. So we are a lot quieter. But what I want to do now, while I'm talking about the ridiculousness, is I'm starting the multi-core test because I want the VRMs to heat up next to it. And the VRMs, if you don't know what they are, it's these bits on the side here. These are VRM heatsinks. Underneath there are basically just these components that help power delivery to the CPU. The more power you're pulling, the hotter these get. And the hotter these get, the less efficient and just lower heat. It just produces more heat. So I'm just gonna put lots of power on the CPU right now to just heat them up is my goal. Okay, I'm enabling PBO, which should mean that, look, our package power draw now, 270 watts. We're pulling a lot more. The fans kicked in now. We can actually hear them. So this is this cooler at its absolute maximum, and we're still about 44, 45 decibels, which means that its maximum is still lower than what we had before. Okay, now I put the pump to maximum speed, or it should follow the speed of the motherboard, which would be maximum. And as you can see, we're dropping the temperatures massively. But still about 44, 45 degrees. We're pulling 280 watts now. Okay, yeah, they're heating up there. I want them heating up. So I've lowered it a little bit so that our thermal camera can actually pick this up very nicely. We're still pulling 260, 270 watts, around 80 degrees Celsius. Now I'm going to put the pump into the quiet mode, back into the quiet mode, which should result into more heat into there. Yeah, see, a couple of degrees higher, 90.1. Let me put it in the middle. Okay, that's in the middle now. See this temperature there? Instantly a little bit lower. I think the middle one is probably, if you're doing any OC, the middle one should be the one. But if you just want quiet, that's perfectly fine in there as well. The tubes are barely warm. But what I want to know now is if this makes a difference. Now you can see a little notch in there. See that in there? This bit goes onto there. So it slots in like that. And then if I plug this into there, we should start to go lower. But first I'm gonna go up there to check what our thermal camera is gonna say. 46.2, something like that over there. Ooh, they're warm now. But then let's apply this fan onto there. Now, even with the other fan installed and this running at 100% speed, we're still lower, a lot lower than the Fantex and previous cooler. Look at that. 44 to 45 decibels. People are gonna say, oh, you just sugar picking these tests. This is literally my test bench that I'm using all the time for testing the AM5 CPUs. And I just pulled one of these out. This was there. I wanted to see, is this any better? Put it in there and look at that. It's absolutely insane. We're able to cool almost 50% more cooling while being significantly cooler, which to me is just insane improvement. Absolutely amazing. You can see the thermal camera print is just lower. Yeah, to the touch, they're a lot cooler. The cool thing about this tiny fan in there is also NOCTUA designed like kind of the ends of the blades and then that little kind of curve and design in there so that it would kind of spin the air out to come out like that rather than directly down to create even better airflow coming out just like that. This is the 360mm AIO. There is the 420mm, which would be slightly louder, but even more performance. What I can say confidently right now is that NOCTUA has done a big W here. By the way, if you want to check out these AIOs, I'm going to leave the link in the description below, as well as in the pinned comments. Go check them out. Bear in mind that fan, if you want for the VRMs, you have to purchase them separately for each one of the AIOs. I highly recommend doing that because it does seem to be making a huge difference. Check that out in the description below as well. I didn't think this was going to impress me as much as I thought. I saw this at Computex at NOCTUA booth and I was like, yeah, it's cool. It's very nice. But I didn't think this was going to be that good. I'm seriously impressed, guys. Let me know what you think in the comment section below.